Welcome to question 6 of the 2018 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video, we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 6, we have two boxes, each contain 4 stones that differ only in colour. For box 1, we know that there are 4 black stones, and for box 2, we know that there are 2 black stones and 2 white stones. So if this is box 1, we have inside it 4 black stones. And for box 2, we have 2 black stones and 2 white stones, which I'm just going to put in a red outline. Reading on from the question, we have a box is chosen randomly and 1 stone is drawn randomly from it. Each box is equally likely to be chosen, as is each stone. And for part A, we are asked what is the probability that the randomly drawn stone is black. So to help answer this question, we're going to set up a tree diagram where the first event is selecting either box 1 or box 2. And because both are equally likely, there's a half chance of selecting either one of those. From there, we have 2 options each time. We could either get a black stone or a white stone. However, for box 1 there are only black stones, so the probability of getting black is 1, and the probability of getting white is 0 after you've selected box 1. For box 2, there's 2 black stones out of 4, which simplifies to a half, and 2 white stones, which is a half. So therefore, the probability of getting a black stone is equal to, and we simply multiply along the branches and then add between the branches. So the first probability is a half times 1, which is the probability of selecting box 1 and then a black stone. And then we add on to that the half chance of getting box 2, multiplied by the 1 in 2 chance of selecting a black stone. And that is going to equal a half times 1 is a half, plus a half times a half is a quarter, which gives 3 quarters. So that is the answer to part A of this question. Now that was a lot of working to get what is a very simple question really if you just look at the 2 boxes we originally drew. Because we have an equal chance of selecting either box and an equal chance of selecting any of the stones within those boxes, there's a 6 in 8 chance, which simplifies to 3 quarters, which we found using the tree diagram. So from the examiner's report, we can see that 79% of students got this question correct, and that the examiners noted that several approaches were possible, which included using a tree diagram or some sort of counting argument. So overall the question was generally well answered. Many students showed their reasoning via tree diagram or some form of written explanation accompanied their answer. Some students overworked the problem by trying to use the binomial distribution, which was unnecessary and irrelevant for this question. For part B, it says it is not known from which box the stone has been drawn. However, given that the stone that is drawn is black, we are asked what is the probability that it was drawn from box 1. So based on the diagram that we have above, we know that there's 6 black stones and we know one of them's drawn, and 4 of those would have come from box 1. So there's a 4 in 6 or 2 on 3 chance of that occurring. Now, just to formalise what we discussed there, we're really looking at the probability that we selected from box 1, given that a black stone was selected. And that is equal to the intersection of selecting from box 1 a black stone, which the intersection would be a half times 1, and that comes from the tree diagram we had drawn out before. And then we divide that by the probability of getting a black stone, which was 3 on 4, also what we found previously. So this is going to equal a half divided by 3 quarters is the same as a half, and instead of dividing we're going to multiply by the reciprocal of 4 on 3, and that is going to simplify down to 2/3, just like we discussed at the start of this question. So that is the answer to part B of this question. So from the examiner's report we can see that just over 60% of students got this question correct, and that students generally recognise the conditional probability and the reduced sample space required. Some students incorrectly worked out the probability of black given it was box 1 rather than box 1 given that it was a black stone that was selected, resulting in a probability that was greater than 1, which students should know is not feasible.